Okay, welcome to the answer key review for Algebra 1, Target 3.2, Solving Systems Algebraically, okay? And we have been using three main methods, something we call elimination, which you'll remember is if both the equations are in if both of the equations are in ax plus by equals c standard form. We've also talked about substitution, which is really just the last step of elimination, but sometimes we can get there directly if one equation is given as x or y equals a number, and then the other equation is given in either form, standard or slope-intercept. And then we've talked about kind of an end-to-end setup. When we have y equals mx plus b, we can just set it equal to the other mx plus b equation if they're both mx plus b. Okay, but when you're doing this work, you're always going to either get x equals a number, or you're going to get y equals a number. Okay, so if that happens, there is one solution. However, there's a couple other strange things that could happen. All the x's and y's could be eliminated. If everything cancels and you're left with two identical numbers equal to each other, such as 2 equals 2 or 3 equals 3, that is what happens when there are infinitely many solutions, and if you graphed it, the lines would be on top of each other. The other weird thing that could happen is you do all the work of elimination, everything cancels as far as the x and the y, and you're left with two different numbers, such as -7 and -9, or 3 equals 6. Well, these things aren't true. 3 is not equal to 6, -7 is not equal to 9. So it creates this false situation, and that is no solution. So looking at this, can x equal 0? Well, sure it can. You could have lots of answers, like 0,8 could be an answer, or 0,3 could be an answer. So this represents one solution. But here we have a false statement. Here they've done some work. Isabella solved a system, and she came up with this. All the x's and y's canceled, and this false statement. Well, then there is no solution. These lines, if she graphed them, must be parallel. Okay, let's get into question 2 through 4. Solve algebraically. Hey, these are both in slope-intercept, or what we like to call mx plus b. So we'll set them end to end. We're going to combine like terms, starting with moving 2x over. Notice I'm using the opposite operation. You're getting -3x plus 24 equals 9. Now I'll subtract 24. I'm trying to isolate the x, so I'm moving everything away from it. Okay? Don't feel bad if during the course of solving it, if you need to use a calculator, you certainly can. 9 minus 24 in this case is -15. Carry down our 3x from over here, and now we've got to divide by -3, and we're left with x equals negative divided by negative is a positive. X equals 5. What's the next step? That's right, substitute. Substitute that into the original equation. In this case, where there used to be an x, there's now a 5. Don't forget to put in the parentheses. So I just used this original equation, rewrote it with a 5 in there. 5 times 5, we have -25 plus 24. When you combine these like terms, y equals -1. So my solution is 5, -1. If we graphed this two equations, they would cross at that point. Be sure on the test, circle, highlight, underline, make sure your answer is clear and show all the work. Okay, here we have a system where we're going to use elimination. They're all in standard form, that is ax plus by equals c format. And all I need to do here is multiply one of these lines by -1. Why? Because we need to make sure that something will cancel. So in this case, I now have these two equations. That cancels. 2x and -2x. 3 plus -6y. That's 3y negative is equal to 12 combined with -6. That's 6. Divide by -3 on both sides to solve for y. And I get -2. What's the next step? That's right, substitute. So take my original equation where there used to be a y. I'm going to insert a -2. Okay, now I multiplied these. I'm solving for x. Add 6 to both sides. Okay, if I was to graph this equation, they would cross at 9, -2. All right, let's look at this last one. All right, here we go. Let's zoom right in on this situation here. A little more tricky because we have both a standard form equation and an mx plus b or slope-intercept equation. There was one like this on the homework. We're going to actually take that whole chunk, since y equals all this. Let's just substitute it in to that first equation where we had a y. So we're smashing these together and it looks like this. -6x minus 5, -6x minus 5. Replace the y with the parentheses for x plus 21 equals -1. So these have been combined, and we've got to distribute -5 to each of these things, because it said -5 times y, and y is all that. So we're going to distribute 5 times 4 is -20. And -5 times 21 is -105. And then we carry down our equals, our -1, and this bit here. Now, these are on the same side of the equation. Here's that equal sign. Some of you I know like to make that wall between them, but on this side they're the same, so I'm going to combine that. -26x minus 105 equals -1. And now I'm going to isolate the variable or solve by adding 105 to both sides. So I have -26x equals, when you combine these, -1 and 105 positive, you get 104. So our last step is 104 divided by 26. But guys, that's not just a 26, it's a -26. So x here equals -4. We're not done. Substitute. Okay. So y equals 4 parentheses -4. Now you could have stuck it into either equation, but this one seems easiest to me. I get y equals -16 plus 21. Well, that's as simple as y equals 5. So my final solution, -4, 5 in the order x, y. And lastly, nobody told me that. I was off the screen there. Thanks. Lastly, we have this word problem. Jacob's school is selling tickets to the spring musical. On the first day of ticket sales, they sold 10 senior citizens and 7 students. Let's, right off the bat, let's make senior citizens x. Let's make students y. You can probably see where this is going already. Using my workspace, I could start my first equation that there was 10 x kind of tickets plus 7 y kind of tickets for a total of $176. Then on another day, they made $304, so 304. Selling what combination? Well, 18 of this kind and 11 of this kind. Well, obviously, we want to eliminate to solve this system. Everything's lined up, but nothing's canceling. And just multiplying by -1 ain't gonna cut it. Let's try and make these cancel. Can you think of a way that we could get a common factor out of these? Well, I'll tell you. The numbers are going to look big for a minute. But if we multiply this by 11 and this by -7, oh yeah, stuff's going to cancel. So, check it out. Stick with me, these numbers are going to look big, but it's really going to come out simple. 11 times 10, 110x. 11 times 7, 77y. 11 times 176, you're going to need a calculator. 1936 is a huge number. Second line, -7 times 18. Again, don't feel bad if you need a calculator, and don't forget it's a negative number. -7 times positive numbers, -126. -7 times 11 is -77y. Do you spot what's happening there? Some stuff's going to cancel. Oh yeah. -7 times 304 is also a negative number, 2128. Okay, now we can do some canceling, folks. That's canceling right out. We're adding up this stuff. 110, -126. Yeah, you're going to probably need a calculator. That's okay. But it's 16 x's. This canceled equals, time for a little calculation here. If you were to put in your calculator, in fact, 1936 plus -2128, 192 negative. By the way, I made a little error here. If we take 110 and subtract 126, it's -16. Final step. Come on, solve for x, you got to divide by -16. So x equals, yeah, I'm going to cheat, 12. $12 is what the tickets cost for the senior citizens. Am I done? No. I need a y value. It asks for the price of the seniors and the students. So I know we're at $12 here. But how are we going to get it? Substitute into the regular original equation. 10 tickets at $12 plus 7 tickets at some price equals 176. Multiply these, you get 120. Subtract 120 from both sides. You get 56 equals 7y. Divide by 7, and you get that y equals 8. Yeah, done. Folks, I hope you don't think this is too hard, because it is the level of the test. If you need more help, come in for tutoring, come in for seminar in the morning or after school. Don't delay, don't hesitate. Let's do it right away. Good luck, everybody, and peace.